Question 9. Question 9 is the subtraction rule, okay? So, the subtraction rule. The subtraction rule is going to be log to the base 2. So it's going to be log base 2, the first one over the second one. So it's going to be x plus 2 divided by x equals 3. Please remember, this is the base number. This one here is the power. This means x plus 2 divided by x equals 2 to the power of 3. X plus 2 over x equals 8. Cross multiply up the 8. So we're going to get x plus 2 equals 8x. Bring over the x. 2 equals 7x because it comes minus x. And then therefore x equals 2 over 7. How many people got that one out? Okay, so good. Yeah, what I'll do is I'll put into the corner here. That's not what I want to do. Just give me a second. Okay. Okay, guys. Can somebody call me out the next question? And what's the next one you wanted again? 13. 13, okay. So can somebody just call me out 13? I'll just do it to the side here so it gives people a chance to copy down this one. So 13 is log x to the base 5. Yeah. Equals 1.
Plus.
Yeah.
Log 3 over 2x minus 1.
Is log base 5 again?
Yeah.
And what is it?
3 over 2x minus 1.
2x minus 1. Okay. What I'm going to do is I'm going to bring this over to the other side. The reason for doing this is if we have two logs on the same side, it means I can use log rules. Okay? So if they're beside each other, it means I can use, and they have the same base, which they do. That's my logic for making that move. They have the same base, so if I put them beside each other, it means I can use log rules. Okay? Now this means that it's going to be log 5, and it's going to be the first number divided by the second number. So it's going to be x divided by 3 over 2x minus 1. Now, what we know is from junior cert is when you divide a number by a fraction, it's the same thing as turning that fraction upside down and multiplying it. So what I'm going to do is I'm going to turn this fraction upside down and I'm going to put it in red so you know what I'm doing with it. I'm going to turn it upside down, bring it to the top. So it's going to be 3 divided by 2x minus 1. Oh wait, I didn't turn it upside down. That's still the same way around. It's going to be 2x minus 1 over 3. And then that means I can get rid of the bottom part. Now it's gone, okay? And all that equals 1. Now what I'm going to have next is going to have log to the base 5 of 2x squared minus x over 3. Does everybody know where I got that from? Multiplied it in. Yeah. Now, remember, this is the power, this is the base. So 5 to the power of 1 equals 2x squared minus x all over 3. Cross multiply the 3. We're now going to get 2x squared minus, that's going to be 15, isn't it? When I do that, yeah? It's going to be 15, then bring the 15 over the other side. So it's going to be minus x minus 15 equals 0. Need a reference number? Reference number is going to be? Minus 30, and minus 30 will break up nicely into minus 6x and plus 5x minus 15 equals 0. Then we're going to factorize out 2x bracket x minus 3 plus 5 bracket x minus 3 equals 0. Then we're going to get 2x plus 5. 2x plus 5. X minus 3 equals 0. The answer is x equals 3 or x equals minus 5 over 2. Who got that one out? Okay, so not really enough, but fair enough. In logs, you can't have a negative number, so you have to actually check it out. So if I have log of any negative number, what the calculator will do is will say it's not defined. So with this minus 2.5, we got to go back to the original question and check it out. And as we can see here, because this one here is x, we cannot get log minus 2.5 to the base 5. This automatically rules out the minus 5 over 2 answer, and the only answer therefore is 3. Okay, happy enough with that? Can we move on?
Yeah, good question.
Sorry?
I've still a question on that.
Yeah, what is it?
Just multiplying just there right here.
17. First thing I'm going to notice is that these two here have the same base. If they have the same base, that means that 3x minus y must be equal to y plus 1. Bring over the other y, we're going to get 3x minus 2y equals 1. There's your first simultaneous equation. This is done in the red. Okay, now we're going to do the blue one, which is this one here. And we'll once again notice that they have the same base. We can do the multiplication rule, which will get me log to the base 3, multiply 2 by x and 2 by y, we get 2x plus 2y, and that all equals 2. Please remember that's the base number, that's the power. This will mean that 2x plus 2y equals 3 to the power 2. 3 to the power 2 is 9. Lucky for us, it lines up very nicely. 2x plus 2y equals 9. You absolutely need to do nothing with it. Add directly down. 5x equals 10. X equals 2. And then if x equals 2, y therefore must be, we can just do it here. 2 times 2, 4. 4 plus 2y equals 9. Bring over the 4, comes a minus 4. 2y equals 5. Y equals 5 over 2. So who got 2 and 5 over 2 for that one? Okay, so a couple of yous there, well done. Any questions on that one? Alternatively, some people would have brought this over the other side at the beginning, okay? So if you brought that over the other side, what you would have got was this. You would have got log 3, 3x minus y, minus log to base 3, y plus 1 equals 0. Then what we're going to get is log to the base 3 of 3x minus y. Sorry, 3x minus y over y plus 1 to the power of equals 0. This means that 3x minus y divided by y plus 1 equals 3 to the power 0. And what is 3 to the power 0? 1. So, and you basically end up with what we ended up with, 3x minus y, which is this part here, equals this one here. It still works, but it's actually a very long way of going about doing it. But it's nice to know you can do it. Okay, number 20. Is anybody for 20?
Yeah.
Yeah. Okay, this one here is a quadratic linear simultaneous, more than likely. Alright guys, log 2, it's going to be 2 over x, red part here. And that equals log 2, 1 over y, 1 minus y. This in turn means that 2 over x equals 1 minus y, which means 2 equals x minus xy. Okay, that's one equation done. Okay, now I'm on the second equation, which is this one here. Once again, so I'm just going to double check the last one. I got the last one upside down. Made a mistake. It's x over 2, excuse me. I knew I made a mistake because it's going to end up with 2 quadratic equations which couldn't possibly work. Sorry guys, got it upside down. Then it's going to be x over 2 equals 1 minus y. X equals 2 minus 2y. And then x, that's a 2. X plus 2y equals 2. Sorry about that. Now on to the next one. Multiply, same base, log 2 into x squared plus 2xy equals 3. Then you're going to have x squared plus 2xy equals 2 to the power of 3. X squared plus 2xy equals 8. Okay, so that's that part there. Now we have two equations going on here. Now, as it turns out, what I did there a second ago, that last line here is actually completely useless to me, because I already had x on its own in terms of y, didn't I? See the line before it, x equals 2 minus 2y. All I have to do is any x's in this equation, replace it with that. And what we're going to get is 2 minus 2y squared plus 2 times x, which is going to be 2 times 2 minus 2y times y equals 8. What I always do is I'll always move the y inside here because it's multiplication. I'm allowed to do that. And now I'm going to square everything out. I get 4 minus 8y plus 4y squared plus 4y minus 4y squared equals 8. Then what's going to happen here is the 4y squares cancel. I'm going to get minus 4y, bring the 4 over the other side, 8 minus 4. Minus 4y equals 4, y equals minus 1. If y equals minus 1, then x equals 2 plus 2, x equals 4. I actually did that one yesterday, I remember doing it. Sorry for change of base. Rule is, which one's the harder version? Never let x be the base. So there's currently an x as the base. Let's prevent the x from being the base. We're going to use the rule where we get 1 on top, and we're going to change the two of them around, like so. Then we're going to say let y equal log x to the base 3, and then what we're going to be left with is, Simon, y plus 3 over y equals 4. And so what happens next is we're going to multiply everything by y, so we're going to get y squared, and we're going to get 4y over y, and this is going to be over y as well. All the y's will cancel. Bring the 4y over the other side, so we're going to get y squared minus 4y plus 3 equals 0. We're going to solve that. We're going to get y minus 3, y minus 1 equals 0. And then we're going to get y equals 3, y equals 1. Then we're going to convert it back into what we said it was. We know that log x to the base 3 equals 3, or log x to the base 3 equals 1. Then we know that x equals 3 to the power 3, or x equals 3 to the power 1. X will equal 27, or x equals 3. Who got that one then? If log x over y to the base 4 equals 5, and x, y are positive numbers, which they have to be, because we can't get a positive number less than 0, okay? Find the values of log 2 to x base 2 and log y base 2. Now, only reason I know to even start this one is this one here. It's one of the rules. Log 4 to the base x minus log y to the base 4 equals 5. Now I'm looking at that and I'm comparing this one here to this one here, and I'm sort of saying to myself, if only that was base 2, my question would be complete. But I have a way of changing them to base 2s. So here's my way of changing the base 2s. See the way it's base 2 is what it's looking for. So it's currently base 4, but I need to change that to base 2. So there's a rule for this. What I do is I take my two of these and I write one of them over the other. And then I pick any base in the world I want. And the base I want is 2. Same thing for this one. I write down log y. It's one of the rules. I write down log y over log 4. And then I pick any base I want. Once again, I'm going to pick log 2. Now, what I need you guys to do in your calculators, will somebody write down log 4 to the base 2? I'm pretty sure it's 2. Is it 2?
Yeah.
Alright, over 2 equals 5. Now guys, Ideally the 5. What fraction would be below the 5? It's currently 1, but what would I love for it to be? 2. So multiply top and bottom by 2, and 5 times 2? 10. Eliminate out the bottoms, and there's our proof there. Log x base 2 minus log y to the base 2 equals 10. You happy enough with that?
Is that what they asked for?
Exactly, yep.
Is that what they asked for? What it is?
Yeah, what's the value of log x base 2 minus log y base 2? Done. Okay. First question. Questions 32 to 39 require a calculator. Solve for each for n. They're actually not too bad. Look at number 33. 5 to the power of n equals 680. What power of n gets you up to 680? Okay? So, guys, what you can do here is, right, if you really want to understand the question, what's 5 to the power of 1? What's 5 to the power of 4 even? Can I tell you what 5 to the power of 4 is? 625. And what's 5 to the power of 5?
3,120.
Now, so look, our answer is going to be somewhere in between 4 and 5, because it crosses the 680 barrier in between those two numbers. Now here's how we do it. Log both sides. Any base you want, but we'll use base 10, okay? Log to base 10, 5 to the n equals log to base 10 of 680. Is everybody happy with that? You just log both sides. You put a log in front of both sides, okay? Now, we use the power rule to isolate the n. The n goes to the front. So we get n log 5 to the base 10 equals log 10 680 here, okay? Bring the log 5 to the base 10 underneath, and now use your calculator to calculate what log 680. You don't even need to put the base 10 in, it's automatically there. So log 680 divided by log 10 to the base 5 to the base 10. What is it? It should be somewhere in between 4 and 5. What's your answer? This here?
You say you don't need to put in the tens right there.
Yeah.
4.05.
Perfect. Exactly what I said, wasn't it? It's going to be located between 4 and 5. Okay.
Wait.
Log to the base 10, lads. Yeah, 4.05s. 3. Okay, next one. Shh, stop it. Okay, guys. Yeah. Next one, 39. Okay, 39 is going to be 5 to the power of 2n minus 1 equals 4 to the power of n plus 1. Once again, adopt the same methods. Log both sides. Log to the base 10, 5, 2n minus 1. On the other one, log to the base 10, 4 to the n plus 1. Do your same trick as last time. Bring your 2n minus 1 to the front using the power rule. And then we have log 10 to base 5. And then on the other one, you're going to have log, you're going to have n plus 1. Bringing the power to the front. Log 10 to the 4. Now, what we're going to do next is, we're going to do a bit of cross multiplication. The n plus 1 is multiply on the left, which makes it division on the right. It's going to divide underneath the 2n minus 1. This one here is multiplication on the left, which means when it goes to the right, it's going to be division. You happy enough with that? Will somebody please put this into the calculator for me? Sorry?
0.86.
0.86. Any more decimals to it?
13531.
Okay, and let's see what they want with regards to answers. Correct the 4 significant figures. So look, that is currently 3. If our answer isn't 4 significant figures, we better work with 5 until the answer. Okay? So 861 what?
3, 5.
3,
5.
5. Okay, Grant, stop there. Okay, guys. Multiply across 2n minus 1 equals 0.86135 n minus. I'm multiplying these two by this one.
Right, goes 1 5.
So you're
Yes.
saying n equals 0.8.
No, I'm not saying that yet. Now, guys, bring the 1 over one side and bring this one over the other side. Sorry, not that one.
Why is it a minus?
Shh. Oh, sorry, it's a plus. Well done, you go. Okay, so what we're going to get next is 2n minus 0.86135n equals 1 plus 0.86135n. Can somebody tell me what that is in the calculator? Just take 2 minus this one here. What do we get?
1.13864.
1.13864.
4.
5.
65. Yeah, okay. Equals, that's n, equals, oh sorry, there's no n on this one. The n is gone, excuse me. Now guys, what is the two of them added together? That's going to be 1.86135. Finally, bring this underneath and divide it. And you're going to get n equals 1.86135 divided by 1.13865. And what do we get? 1.634. Now stop there. How many figures do we have? 1, 2, 3, 4, 5, 6. We need it to 4, so it's 1.635. That's 4 significant figures right there. Okay. Last iteration. Alright guys, I'll take the last one. Shh. Quiet, alright? What I'm having here is, I'm also going to write down one thing here. E to the 2x equals e to the x squared. That's y squared. You're going to need that later on. Now, I'm going to do this one here. 3 e to the x minus 7 plus 2. Now, e to the minus x equals 1 over e to the x by the rules of indices, okay? So the question rewrites itself into this. I'm going to let y equal e to the x. That's how I do all of these questions. I'm now going to get 3y minus 7 plus 2 over y equals 0. I'm going to do what we've done all this chapter. Add on y's. And then I'm going to cancel them all. I'm going to be left with 3y squared minus 7y plus 2 equals 0. What's then going to happen is I'm going to get the reference number of 6. When the reference number is 6, what I'm going to get is, what's a minus 6 minus 1? So I'm going to get 3y squared minus 6y minus 1y plus 2 equals 0. I'm then going to factorize out the 3y into y minus 2 minus 1 into y minus 2 equals 0. Then I'm going to get 3y minus 1 y minus 2 equals 0. I'm going to get y equals 2 or y equals a third. I'm confident a lot of you will get there. The problem area is the finishing. E to the x, okay? Now there's a button for e to the x, okay? This means that e to the x ends up to be a third. E to the x equals 2.